Okay, so the last video got corrupted, so we're just going to create another one and take periodic breaks to take a look at the recording software to make sure it's fine. So this is going to be a quick run through. The two main things we want to focus on is array bag and linked list bag. So let me get everything back in order real quick. So as you told us, node needs to be inside of the linked list bag, the linked bag. Head as always, size. We understand all this. We're not going to go through a huge rudimentary talk about all this because we've worked on projects that included these. Default constructor here, but I did end up using another constructor call inside of this to set the next to null. You'll see why in the future. Because I wanted to be able to do something really cool, but I didn't need to specify it, but I wanted to work on concrete statements this time. Data is going to be what we put in, so it's going to be the string that we put in, which is going to be the value that creates the node itself, and next node is going to be created in the null. If we don't have a next node that we want to specify, we're just going to set it to null via the basic constructor, not the more defined constructor. I believe we refer to this as method overloading. Next, linked bag, creating it, size 0, null head. Size, we're going to get the size. Empty, we're going to get empty, based off the return statement size equal to 0. Adding new entries. So what we do is we create the new entry, right? We set the new node net.next as the head. Sorry, I just brain farted. So what happens is we have new node. So new node is going to be considered the new head, right? But then we're going to set new node.next equal to head. So then the next one, so we'll have so we'll have 1, 2, we'll on a realistic world have 3, 4. And then we will do, we'll create a new node, which is going to be 1, but then we add everything after, which is going to be 3, 4. Remove, so what we're doing is if the entire linked list is already null, we're going to simply return null because we can't remove anything else. We're going to do removed data.head.data, because we're just going to remove the first thing in the bag, and then we're just going to set the head to the next one because we were still linked. Size decrease, return remove data. Removing a direct string entry, what we're going to do is set the head to the current node to head, previous node to null, so I want to be able to keep track of both sides. So what we're going to do is while the current node is not equal to null, we're going to do a for loop, basically a for loop of this, but it's a while loop. So if current data is equal to an entry, we're going to make sure the previous node is not null. If it's not, we're going to set the current node to next, which is going to be the hold up. If the previous node is equal to null, we're going to set the head equal to the current node.next. Else, we're going to set the previous node.next to the current node.next. So this means that we're going to, I need to explain it easier, we're going to have 1, 2, 3, 4, and then we're going to have the previous node set as null. If it's equal to null, we're going to have head equal to current node.next, so we're just going to take the next one, which is 3, 4. Else, if we do have a previous node, let's say we're removing 2, we'll have 3, 4, 1, 3, 4, because the previous node's next is going to be the current node, so it's going to go, so we know that we're on 2, so then it's going to bounce to 1, and then this right here is going to set it to the current node.next, so it's going to outright just remove 2. So it's going to continue doing that until we either find it or don't. If we don't find it, it's going to return false. If we do find it, it's true. Downsize. Clears, clear, basic. Get frequency, we're going to do a while loop and just frequency iterate every single time we find a match for in entry. Here we could have used dot equals ignore case, but dot equals was fine here during the testing cases, or else I would have went back and changed it. Contains, we're just going to see if it contains a string of our choosing. So we're going to do a while loop while current node is not null. We're going to check the data and return it true. If it does become null, we're just going to return it false because it's not in there. To array, we're going to create an array with the size of the entire linked list. Then we're going to do a current node is equal to head. That's just so we can iterate. Index is going to be 0 because we start at 0. While the current node is not equal to null, we're going to continue to iterate and check we're going to continue to iterate using the data and then setting the data as the index. So we're going to start at index 0. Index 0 is going to be the data of that selected node during the while loop iteration. Then we're going to set the current node to the next one. Index is up. Then we just continue until we get to the end, return the result. Removing duplicates. So there's multiple ways to do this. I chose to do it this way because it was easier for me. Size, if it's less than 1 or equal to 1, we can't because there's no way for a duplicate. Current node is going to be head. We're going to do a while loop. So think of this as a double for loop, right? So we're doing a double for loop here, basically. So you know how we did the for loop I for j. It's basically a for loop I for j. We're going to use runner as our back and forth checker. So we're going to use runner. If the runner is not equal to, if the next is not equal to null, then that means we know we can continue to go. We're going to make sure the data of runner is not equal to the current.data. If it is, we're going to set runner.next to runner.next, which is 1, 2, 3, 4. If we know that, we'll do 1, 2, 3, 1. If we know that 1 is a copy of the original, we're simply removing it. And then we'll do 4 because next forces that. It's forcing the next one because we're checking runner.next data and comparing it to the current node. Else runner equals runner.next, so we're just iterating to the next runner because the while loop. So we're basically always going to check the next one for runner. Against current node. So if we get done with a full iteration, we're gonna up the current node, and while current node's null, we're gonna continue in this iteration loop. Contains all. This is simply checking. Here's something from my earlier description because of class, because data corrupted. Contains all bag interface. So we just want to make sure that one bag contains everything of another bag, so bag 2 needs to contain everything bag 1 contains. So we know that we have 1, 2, 3 because we use contains, so we just make sure that the item's in there. It doesn't matter. Well, here it doesn't matter if there's a frequency because we just want to make sure it contains the item using dot contains. If it does not contain, we're returning false. If it does contain, we do. This is a for each loop, which basically loops over like a for loop, but it's for each item that's in there. Same items, we want to make sure that the bag is the same items, making sure that the size is the same first. If it's not, we return false. We make a copy of bag. What we're doing is we're making a copy of the bag here and setting it as bag items. .toArray, simply calling our toArray list up at the top. Doing a for each loop, and we're going to check the frequency. So this would be this dot frequency, but I didn't use it that way, but it's basically saying this dot frequency not equal to get frequency of item. If the frequencies aren't the same, we're going to false. If it is, true. Now let's go into the array bag. Hopefully this one isn't corrupting. It looks like it's fine so far. We're 9 minutes deep. Array bag, creating it with the initial constructor of K.